Welcome back, guys, and in this tutorial we're going to be starting our study of tangents and circles. Now, we've already met the word tangent before. A tangent is a fancy word for a line that touches a circle at one point only and is perpendicular to a radius, which means our general formula or our general diagram that shows a tangent is here, where we have the centre of the circle HK. We have a point P where it touches the line of the tangent, and we know it's perpendicular, so it's 90 degrees to the length of the radius. Okay, now this is a property we need to remember about the tangents as we look at solving problems involving tangents. So in example 1 here, it says show that the line x plus 6y minus 9 equals 0 is a tangent to the circle x squared plus y squared minus 4x plus 10y minus 8 equals 0. Well, the first thing I would see here is I need to find the centre and the radius of this circle. So I'm going to write out the formula they've given me. X squared plus y squared minus 4x plus 10y minus 8 is equal to 0. And then I'm going to write out the general formula from page 19 in my log tables. X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So I can see when I look at these now that 2gx is going to be equal to minus 4x, 2fy is going to be equal to 10y, and c is going to be equal to minus 8. So I'm going to let these equal so I can find g, f, and c. So if 2gx is equal to minus 4, I see my x's cancel on both sides, and I'm going to divide both sides by 2 to get g. When I divide both sides by 2, I get g is equal to minus 2. Now I do the same thing for f. So I have 2fy is equal to 10y. My y's cancel on both sides, and I'm going to divide both sides by 2, which means I get f is equal to 2. C is a bit more straightforward, where it's just directly related, so we get C is equal to minus 8. So now, using our formula again from page 19, I can see that the centre, which has the formula minus G minus F, would give me, minus by minus makes a plus 2, and a minus here by 5 gives me a minus 5. Then I can find my radius using the formula G squared plus F squared minus C. So I get the square root of 2 to be squared plus minus 5 to be squared minus by minus 8. So I get 4 plus 25 plus 8, and we need to get the square root of that number, which gives me the square root of 37 units, and I'm going to leave it as the square root of 37 units. Okay, so now I can start drawing a diagram to help me figure this out. So if I drew a circle with the centre 2 minus 5, and I have a circle like this, I know then that the point or the line x plus 6y minus 9 equals 0 would have to be hitting a point if it's going to be a tangent. Okay, and that would mean the perpendicular distance between the centre and that point would have to be equal to the radius. So I'm going to use my perpendicular distance formula using the centre and the line and see if we get the radius. Okay, and if we get the radius, then I know it's a tangent. So in this case, I would know A is equal to 1, B is equal to 6, and C is equal to minus 9, and my x1, y1 is going to be my centre. And again, I'm going to use the perpendicular distance formula from the top of page 19. So if the perpendicular distance is equal to ax1 plus by1 plus c in the modulus, all over the square root of a squared plus b squared. And now we're going to fill it in. So that means I get the modulus of 1 by 2 plus 6 by minus 5 minus 9, all over the square root of 1 squared plus 6 squared. Okay? So I get the modulus of 2 minus 30 minus 9 all over the square root of 37, which means what I actually have here is the modulus of minus 37 over root 37, which I know is going to give me the modulus. I can assume that the number inside the modulus is a positive, and I have 37 over root 37 If we take a second here, guys, to put 37 over root 37 into our calculators, we'll see that that simplifies to just give me root 37 when I rationalise the surds. So now I can see that the perpendicular distance root 37 is equal to my radius, or. But now I need to give a conclusion. So therefore, the perpendicular distance is equal to or, so the line is a tangent to the circle. Okay, and we have to always give a conclusion in questions like this when it says show at the start of the question. So take a minute there, pause the video, guys, go back through example 1, and then we're going to look at example 2 when you're ready. So example 2 here says find the equation of the tangent. So this time they haven't given me the equation, but they're telling me for definite that it's a tangent. To the circle, x squared plus y squared minus 4x plus 2y minus 20 equals 0. So again, to start off here, before I do anything else, I'm going to write out my general equation above the circle equation they've given me to help me find my centre and my radius. So I can see here again that 2gx is going to be equal to minus 4x, 2fy is going to be equal to 2y, and c is going to be equal to minus 20. Again, I'm going to divide, so my x's cancel, I divide both sides by 2, my y's cancel, I divide both sides by 2. So I get g is equal to minus 2, and f is equal to 1, and c is still equal to minus 20. So from page 19 again in my log tables, I know my centre is minus g minus f. So I can see that my centre here is going to be a minus by a minus is a plus 2, and a minus by a plus is a minus 1. My radius, I'm going to use the formula g squared plus f squared minus c. So I'm going to sub in what I know, which is minus 2 to be squared, plus 1 to be squared, minus by minus 20. Being careful of our signs here, guys. So we get 4 plus 1 plus 20, which gives me the square root of 25, so my radius is 5 units. So now let's draw a little diagram here. Bearing in mind it says that it's a tangent at the point 5 minus 5. So when I draw a little diagram here, I have my circle. I've just determined that the centre of my circle is 2 minus 1. I know that a point on my circle is 5 minus 5. And I know the radius, or, is going to be 5 units. Since it's a tangent, I know it's perpendicular. So now that I have these 2 points, I can label them x1, y1, x2, y2 to be able to find my slope. So we have m is equal to y2 minus y1 over x2 minus x1. Because if I find the slope of the radius, and I invert it and change the sign, flip it and change the sign, then I'll have my slope of my tangent, which means I'd be able to use my equation of a line formula, because remember, a tangent is just a fancy word for a line, with the point 5 minus 5 and my perpendicular slope to find the equation of my tangent. So let's try and sub those in now. So we're going to have minus 5, So we're going to have minus 5 minus minus 1 all over 5 minus 2, which means I have minus 5 plus 1 all over 3, which means here I'm going to have minus 4 over 3, so my perpendicular slope would be positive 3 over 4. So now here I'm going to use 5 minus 5 has to be the point I sub in for the equation of a line, because it has to be on the tangent. So we cannot use the centre, we have to use 5 minus 5. So we're going to have y minus minus 5 is equal to 3 over 4 by x minus 5. To get rid of the 4 on the bottom of the fraction, I'm going to multiply both sides by 4, which will get my 4's to cancel because it's the opposite to divide. Okay. Then I have 4 by y gives me 4y, minus by minus 5 is plus 5, and 4 by plus 5 gives me plus 20, is equal to 3 by x is 3x, and 3 by minus 5 is minus 15. So now I'm going to bring both of these to the other side. So I get minus 3x plus 4y plus 20 plus 15. So we get minus 3x plus 4y plus 35 is equal to 0. And if you wanted your x to be positive because it's at the start of the equation, we can multiply by -1, but we don't have to, but it's nice to clean it up. Okay, so I get 3x minus 4y minus 35 is equal to 0. And this is now the equation of my tangent. It's my final answer. So pause the video here, guys, take a minute, go back through example 2, make sure we add it into our notes booklet, and then we're going to try a few questions. Thanks very much, guys. See you later.